Routing in networks relies on two key components: algorithms and protocols. Routing algorithms determine how to select the best path for forwarding packets through the network. These algorithms are responsible for calculating and populating the routing tables with the most efficient routes. On the other hand, routing protocols are used to exchange reachability information between routers. They ensure that routers remain updated about the state of the network and can adapt when topology changes occur. So, in short, algorithms decide how to route, and protocols ensure routers know what's reachable. This example shows how routing tables are populated using routing protocols. Let's look at router R1. R1 doesn't know the full network topology by itself, so it relies on information shared by neighboring routers through routing protocols. For example, router R2 can inform R1 that it can reach network A and network B, so R1 adds a route for those networks via IP1, R2's interface. Similarly, R3 tells R1 that network C and network D are reachable via its path, so R1 adds them through IP2. And for network E and network F, the information flows from R4 or R6, and R1 adds those via IP3. So routing protocols allow routers to say, from here, you can reach these networks, enabling R1 to build a complete and accurate routing table based on the best paths to each destination. Routing algorithms are responsible for choosing the best path to forward packets across the network. They're typically based on minimum cost or minimum distance, where cost can mean different things, like the number of hops, the capacity of a link, delay, or even how congested a path is. The routing algorithm calculates this cost and builds the routing table by selecting the next node or next hop for each possible destination. There are two main types of routing: static routing, where paths are manually configured and don't change automatically, and dynamic routing, where routers exchange information in real time and the tables adapt to changes in the network. Dynamic routing is more complex, but it's essential for large or frequently changing networks. Static routing is the most basic type of IP routing. It doesn't rely on any communication between routers. Instead, the routing tables are manually set up by a network administrator. This happens in two stages. First, during the design phase, the administrator decides which route each router should take for every possible destination. Then, in the configuration phase, these routes are entered using commands or scripts. Static routing works well in small or stable environments, such as network edges, ISPs with simple topologies, or for load balancing, especially when we want to route traffic in a specific way for security or privacy purposes. Dynamic routing is based on selecting the shortest paths within the network. The network is modeled as a graph where each link is assigned a cost, or weight, which can represent metrics like delay, bandwidth, or hop count. The goal is to compute the shortest path tree from a router to all destinations. This is equivalent to finding a minimum spanning tree, and the key advantage is that routers can compute this in a distributed way using routing protocols. There are two major classes of dynamic routing algorithms: distance vector, DV, where routers exchange information with neighbors about the distance to destinations; link state, LS, where routers share complete topological information, and each independently computes the best path. These algorithms enable efficient, adaptive routing in large and changing networks like the internet.